Ugh, what'd I miss?
Well, Colin, you see, you missed integration by parts, which is a method of evaluating integrals in which two terms are multiplied by each other. And the way we evaluate integrals by parts is with the formula u v minus the integral of v d u. Now I'm going to throw it over to Colin, who knows how to do this, to explain how to get v and u.
Oh, this is not going to be 5 minutes. Oh, I remember. Alright, in order to find what u and dv equals in by parts, we use an acronym process called LEAT. The L stands for logarithmic functions, which can be log or a natural log. So for example, in a by parts integral, if it was log 2x 3x squared, the u would equal log 2x, because that is the first example in LEAT. So the I in LEAT stands for inverse trig. So an example of this would be arctan, or tan -1, stuff like that. So when you use this in an integral with by parts to find a u, so that's the first variable you find. And it can be something such as tan -1 x 3x squared, and this would be your u. A in LEAT stands for algebraic functions. An example of this in the integral would be 3x times tangent x to the dx. That's not how it's like. T in LEAT stands for trig, which is just pretty simple equations, pretty textbook, like tan x or cosine x. So in the integral, for example, you'd have tan x times e to the x. So your u would be the tan x. The E in LEAT stands for exponents. So an example of an exponent, as we know, would just be like e to the x. So in the integral, for example, if you have 3x times e to the x, the u would be the algebraic. So here you have u, 3x, and then the LEAT, you get to the e, which is exponents, which would be right here. So that is your dv. And then you can find that. Then you find the inverse. Oh, Jesus. And you take the derivative of 3x, which is just 3, and then the antiderivative of e to the x is just e to the x, as we know. And then there you have your by parts, and then you can sub it into this formula. And that, folks, is LEAT.
So for example, we got the integral of x times e to the negative x. So right away, there's not room for manipulation. So when in doubt, go by parts. And so we're gonna label, so from LEAT, we're gonna start, since there's no logarithms, there's no inverse trig, so we're gonna go to algebraic. And this x right here is algebraic, so we're gonna label this our u, and the rest are dv. And so we plug it over here, u equals x. The derivative of du is dx. For our dv, we put e to the negative x dx. So then we get to the antiderivative of this, of e to the negative x, which is negative e to the negative x. And then now we apply our formula. So we go u, which is x, our v, which is negative e to the negative x, minus our integral v, which is e to the negative x, and then dx for du. And then is to bring this negative out, and then to solve this integral. But first, we're going to take out the -1, so this will become positive. But the integral of e to the negative x is just negative e at negative x. So you have another negative, and a positive times negative is a negative. So it stays negative, and the e to the negative x stays the same. And because it's an indefinite integral, you add your plus c.
Teacher Sam,
Thomas.
what happens if you wanted to solve it as a definite integral and it had bounds?
It's a great question. So for our bounds, we'll use 2 and 0. And because it's a definite integral now, our plus c doesn't exist anymore. So now we have our bounds, we have to integrate, we have to plug in the bounds, and you plug in 2 for x, and then you subtract whatever you put 0 in for this whole term.
Is that what it looks like at the end?
Yes, that is what it looks like.
That has been by parts.
Oh, I think I understand it now.
Minus, and the antiderivative of this is just, I don't know. And we're going to put, since, I don't want to explain that.
This function.
That's after 2 and 2.
No, but
Yes,
that's the
if
derivative.
this is equal
Will
to.
this become 2 and 0? That was you just took it.
Oh, Chaz.
Chad, that was a pitfall.
You were so
Chad,
dumb.
pitfall.
I don't even know if it's a pitfall because it's just dumb.
Yeah.